The sort of important chat post-draft. So the ideal is that we've sort of received our drafts, considered our feedback, and now I'm just have a bit of conversation about some of the things up here. So the first thing is final. The due date that I've set is Friday next week. I understand it's a big task, so if you think you need more time, make sure you ask for an extension early, and I'll be very happy to comply. Now I want to point out, like, this is a massive task, right? It's a really big task, and it's lots of work, but it's 20% of your overall grade. And so, like, when you work that out, that's like the same as 2/3 of the exam, or you can think of it as 3 tests. So if you think of the amount of work that goes into 3 tests, all right, so let's just take last term. The 3 shortest tests were chapter 7, chapter 4, and chapter 5. We did that over a whole term. A whole term's work was dedicated to 20% of your grade. All right, and so that means perhaps our efforts in the folio should mirror that in terms of the amount of time we allocate to it. So don't complain about how much work it is. It's 20% of your grade. It's supposed to be a lot of work. Okay, so that's the first thing. Lots of work. The second thing is it's a challenging task, but it's set up in such a way to allow a lot of success. So if you do all the things that I tell you and you consider everything on the checklist, there's no reason you can't get an A+. So last year I had 30, maybe 31 students in methods, and I think 16 of them got an A+ in this task. So that's like over half. So you just have to do all the right things, tick all the boxes, you do very well. It's a task that it's complex, but you can do well in it. So I've emailed to you a video that's me scrolling through your document, okay? Now people are gonna have different length videos, and that's not being biased in any way whatsoever. Generally, the length of your video should mirror how much work you need to do. Every now and then I get stuck with formatting, or I get stuck going down a rabbit hole describing something. But if you feel there's something that I haven't addressed, please ask me about it, because it's not like, oh, you're done with your draft now. No, I want you to ask questions. Maybe I've said talk to me about something in class. Sometimes it's better to have a discussion one-on-one than it is conveying that information through a video. So ask me questions, and if you feel there's anything I haven't addressed, please speak to me about that as well. But I want to make sure I'm fair and equitable, giving everyone the same amount of feedback. And everyone's got access to 2 things, okay? So I've got a general draft feedback document and a general draft feedback video. So the video goes through common errors or not common errors, but common things that a lot of people need to address. And so that's just sort of a point of access where everyone can access it when they're ready to add that component into their folio. And the document, I'll scroll through it now, it provides a lot of prompts as far as how you need to structure the essay and so forth. So there's a bit of a checklist to go through here, you know, and these are the sort of points to make sure that you're satisfying all of the requisite contingencies for the folio task. So everyone's got a copy of this, and if you're not sure what any of it means, ask, but you should be satisfying all of these in order to make sure you get the best grade possible. So I'll keep scrolling through. I've talked about the performance standards. We're assessing every single performance standard, so following through there, proofreading it, and saving it as a PDF. Then I've got a massive list of discussion questions. Now it's not that you need to hit all of those, but rather those are directions in which you can investigate, all right? Really in the discussion, there's 3 components to it. You talk about what are the assumptions that you've made, firstly in developing the wine glasses, but also in using the technique of rotating functions around the x-axis. What are the limitations of your wine glasses, but also, again, of the technique of rotating functions around the x-axis. And then probably the most important one is the reasonableness of your results. We're performing these calculations in order to compare them to real life wine glasses, all right? How do they hold up? How do they stack up? So all that there. And then the curriculum statement. So this is what the subject outline lists for a mathematical investigation. Probably the only things I want to point out here are these constraints that they have here. Maximum page limit is 15, okay? Now that does not include the bibliography or the appendix. So bibliography we know is for writing where you put your references, and the appendix, what goes in an appendix, a question I often gets asked, is what we call non-essential calculations that still contribute to the argument presented in the folio. Okay, so non-essential, anything that's essential needs to be displayed in the main body of the work itself. What else? And they say size 10. I have seen students in the past get away with less, but you know, these are the instructions from SAY, so just stick within that. You can have narrow margins, that's fine. 15 pages is plenty. Okay, so that's the general draft feedback document. Similarly, the video, it goes through 4 things, and I think probably most people, this was the feedback I gave to them. The first thing is that in the introduction, you need to develop the conjecture. A lot of people at the start, they just had it stated. So I'll talk about that now. I've talked about it in the general draft feedback video, and I developed it when I was going through the first video that you watched that introduced it. But that's just to say, you know, what we're doing is we're imagining we're standing on the x-axis, we're looking towards the point of origin, we've got a function there, and we're going to imagine rotating that around the x-axis. Now we know with integration that we can approximate this area using rectangles, right? In fact, we can find the exact area using an infinite amount of infinitely thin rectangles. And if we rotate a rectangle around, that's generating a cylinder. So our hypothesis is if we rotate, if we have pi times the function squared, okay, the function squared, because for each value along here, you have a differing radius of the rectangle, all right, and integrating over a certain domain from A to B. So building that up, talking about not just making it an argument by assertion, but building up saying, we're going to test if it's true. And then what are we doing in part A? We're investigating a cylinder to see if it works. We investigate a cone, and we see that it works for the cylinder, it works for the cone, it works for the ellipsoid. We've got good warrant to believe it's true, and so then we're going to use that to investigate properties of wine glasses in part B. So introduction, develop it. Part A, prove it. Part B, use it. All right. So that's as far as the introduction goes. Now, another strong critique is, moving away from this sort of question-answer format and using diagrams to communicate your mathematics, okay? The diagrams should help you out and should aid, so you should have the text integrated with the diagrams, integrated with the mathematics, all combined to communicate it, so that when you're reading it from the top to the bottom, like it makes sense to someone who's picking it up and reading through it. Now, this isn't something that you have to hit, but I think it's good because it demonstrates an understanding of, first, the distinction between inductive and deductive reasoning and evidence, but also because it's how we build up conjectures in a test scenario and in the exam situation. So what I mean by that is we perform, when we're doing, let's take it through the cylinder for instance, we investigate a cylinder with a radius of 3 and a height of 5, and we see that it works in one case, and then we leapt straight into the general proof. But one thing we do when we do a test is we often have a table, right? And so, like just for example, with the cylinders, you know, we had cylinder 1, cylinder 2. So our first cylinder had a radius of 3 and a height of 5. And we saw its volume was 45 pi using the volume formula. And using the integration technique, so I'm just going to put here, using the integration technique, we saw it was 45 pi as well. So then what we can do, we've got one piece of inductive evidence, and all that does for us is prove that it works for these dimensions. All right, and I mean, this is how the whole enterprise of science works, right? It's about making observations and then reaching a general conclusion. So we can choose a cylinder with different dimensions, okay, 20 and 30. And we check that it works for these as well. Not that you have to show those calculations, but rather this table demonstrates that you've understood what each specific case shows, and then you launch into the general proof. You prove it in general terms. And the proof in general terms is what we call a deductive proof, because it proves it in all cases. It doesn't matter what the radius and the height is, it's proved it for all circumstances. So doing that for the cylinder, the cone, and the ellipsoid. It's just a matter of adding a table in, putting some numbers in, and saying that the calculation works. Okay, so that's the inductive evidence. And what have I written there? Repeat. Don't repeat yourself. So that's one thing I sort of saw popping up a bit, is maybe a bit of copying and pasting of certain things. So with a report, you know, this is something that you say back in year 8. People say, how many words should it be? And the correct answer is as little as possible. All right, so in a math report, we want to be concise. That means we're saying what we need to say. We're not waffling any extra rubbish or repeating ourselves. We're being short, sharp, shiny. You see passive voice as well is the other way to, the other thing we need to make sure we're doing. All right, so I'll stop the video there.